Welcome back to Physics 30. This is the Unit 2 first booklet, Friction Forces Part 1. Pertains to pages 3 to 11 of the Friction Duotang. So the objectives here are to look at limiting static friction force, static friction, kinetic friction, normal force, coefficient of kinetic friction, and coefficient of static friction. Explain that friction forces oppose motion. Give examples of some moving objects which eventually come to rest due to friction. Explain that sufficient force needs to be applied to an object before it will begin to move due to that friction. Identify situations in which it is desirable to increase or reduce the amount of friction between two surfaces, and compare the static and kinetic friction forces acting on an object. So in general, we can think of three types of friction in physics: sliding friction, two objects slide across each other; rolling friction; and fluid friction. Looking at each of those in detail, sliding friction makes it difficult for surfaces to slide over each other. Rolling friction opposes the rolling motion on a surface, and fluid friction, that resists motion between liquids. The word fluid there also not only applies to liquids but also gases. So like when you stick your hand out of a window in a moving car, that friction force that you see there is also considered fluid friction. And of course, when building vehicles or technology, engineers try to minimize friction so you get a bigger bang for your buck, you get more gas mileage, etc. Okay, clearly a distinction between static friction and limiting static friction. So both of these are static friction. The word static implies something is at rest. So friction at rest. The friction that prevents an object from initially moving. So if you're trying to push a brick along a table, the brick doesn't move even though you may be pushing on it, because that starting friction is preventing it from happening. And of course, if you push a little harder, it begins to move. So that maximum force that you need to apply just to prevent movement is called the maximum, or the limiting static friction. Okay, so static friction is friction that prevents an object from moving. The largest force you can apply before it starts to move is the limiting. It's the limit of that static friction. And of course, to get something moving, you have to have a force applied that's bigger than your force of friction. So here, if our red arrow represents friction, our applied force has to be a little bit bigger. If it's the same size, it'll cancel that friction off. But if it's a little bit bigger, and if this thing was originally at rest, we'd have to accelerate it a little bit by having a net force involved there. So static, things at rest. Kinetic implies moving. Force of friction that oppose the motion of a moving object. So the friction that is working against you as an object is moving. And of course, that friction is less than the static friction. So kinetic friction is always less than static friction, or starting friction. It's more difficult to get an object moving than it is to keep it moving. Just like pushing a stuck car during the winter time. You know it's hard to get it moving, but once it's moving, it's easier to push, because kinetic friction is less than static. Okay? Reasons for that: if you imagine all surfaces, if you were to take a microscope to a surface and look at it, it wouldn't be a flat surface. It would likely have jagged edges on it. And you can see with this, kind of looks like a monster face, once it's at rest, these areas have a chance to interlock with each other, making it difficult to move. But if the top one was moving with respect to the bottom, it wouldn't have a chance to interlock, so the friction would be less. So at rest, objects interlock with each other. When it's moving, the interlocking does not occur to some extent. Okay, so that's kind of a reason that why the friction at rest is bigger than moving friction, or kinetic. Two other factors that determine how much friction is present: the nature of the two objects themselves, so wood on wood, asphalt on rubber, etc., and also the normal force, the force that is, if we're talking about a object that's flat on the ground, it's the force that opposes gravity. It's the force that the bottom surface is pushing up on the object so it doesn't go into the ground. So for example, a table holding up a book, that normal force would be the force that the table exerts on the book. So to figure this out, it just helps you figure out how much friction is present. These two variables, kind of taking the nature of the two surfaces into account, and the normal force of friction is equal to, this is the Greek symbol mu, which is coefficient of friction. It depends upon the nature of two surfaces, so this as a value that you'd have to look up, which is dependent upon the surfaces that are interacting, and the normal force, which is the force that the object exerts on the other object. If it's this case, it's just the opposite of gravity. And we can rearrange this, solve it for mu, the coefficient of friction, and get it's the ratio between the force of friction and the normal force. So of course the more friction involved there, the larger that coefficient of friction value will be. And yes, as I mentioned here, that this equation basically involves these two items, nature of objects and normal force. So that coefficient of friction relates to the nature of the objects. Now, some things that friction does not depend upon, if you have an identical object, and if you orientate it this way or another way, the surface area of contact has no difference because it's the same object. So mu doesn't change and the normal force doesn't change, because over here we have this small surface on the table with a large normal force because you have all this mass above that, whereas here you have more surface area but a smaller normal force, so it all balances out. So the object is staying the same, so mu doesn't change, and also the normal force doesn't change, because if you have a small contact area, then you have a large normal force. If you have a large contact area, you have a small normal force. So these two are always result in an equal force of friction in both cases. So be careful with that. The object has to change, or the normal force has to change. How is the coefficient kinetic of friction and by moving? How's that? How are they determined? So just like I mentioned before, no matter what the coefficient is, whether it's kinetic or static, it's calculated the same way. Friction over normal force. It's just here you have to be more specific. If it's the coefficient of kinetic friction, using the kinetic friction force. If it's the coefficient of static friction, you're using the force of static friction. Okay, so you may see this detail described in there, showing whether it's kinetic force or static force. And as previously mentioned, static force is bigger than kinetic. At rest is larger than moving because of those interlocking surfaces. And I mentioned this is the Greek symbol, pronounced mu, etc. So if Fs is bigger than Fk, then Us must be bigger than mu k. And what types of values are possible? Remember, the limiting static is the maximum force that you can apply before the object starts to move. So the word static in general refers to that whole force, but when you're talking about the upper limit, that is the limiting static friction. So somewhere in between 0 and the limit that you could possibly reach. And then the vocab here, folks. Limiting static friction force, the maximum value of friction which prevents movement. So if this is my static friction force, if I apply a force in the opposite direction equal to that, the object is ready to move. If I apply just a slightly larger force, the object will move. Static friction in general. So this is a general term, whereas the word limiting is more specific about the upper end. Friction that prevents object moving. So all friction force that prevents movement, whether it's from 0 to the limit, that is all static friction. Kinetic friction, friction that opposes a moving object. Now, if this object is already moving and we have a kinetic friction force, if I apply an equal and opposite applied force, the object just keeps moving the way it was, constant velocity. Because this force is balancing this force, the object will be moving at constant velocity since there's no net force, and with that there's no acceleration. Okay, and oh, there's a few more on this page here, and then I think that's it. I have some friction hints at the end we'll take a look at. The normal force is the reaction force of Fg if you're talking about a flat surface. We'll look at situations that aren't flat. So the force of gravity we calculate by mass times gravity acceleration, and it's equal and opposite, so if we take the negative of that we get that, but that'll come into play later on. Also, normal force is referred to as the perpendicular force between the surfaces. Coefficient of kinetic friction, the ratio of kinetic force and the normal force, whereas coefficient of static friction is the static friction force over the normal force. So notice here I don't use FF for friction. I try to be more specific in stating whether it's kinetic or static. Okay, so I have this. Maybe we'll take a look at just the first part, or actually I think I might save this for the next booklet because it'll make more sense there. This first booklet here is just mostly a qualitative treatment of it, and then before I look into the next book, or at the end of the next book, we'll look at those hints at the end. Okay, see you soon.